Ladies and gentlemen, thank you. Here we go. Another week of review. This is chemical reactions balancing. So we're going to work on is looking at the different type of reactions we're going to cover this semester, and then how to balance those reactions, the easy ones. So let's take a look. We've got 5 classes. The first one is what we call synthesis or composition reaction, where we take 2 elements and make 1 compound. And basically, for a balanced reaction, it looks like 2H2 plus O2 will give us 2H2O. And this is our A, this is our B, and this is our C. So you could, substitute A, B, and C for the chemicals in the reaction. And this is how we know we have a synthesis and composition reaction. And then we have what we call a decomposition reaction, where A goes to B plus C. So one compound in an application of heat, light, or something, add energy to it, and we get two products. And most of the time these are elements, but they could be other products as well. So here are 2 examples, and we usually, people usually do is 2H2O mercury oxide. We go to 2Hg plus O2. That's one. And another one is just what we call dehydration, calcium sulfate. And this usually has some water of hydration with it. This means there's water in the crystal. And if we add heat, we get calcium sulfate plus 6 waters a molecule. This is another decomposition reaction. This is a more advanced type of reaction, this one, than this one on top, but it's the same thing. So here's one compound, add heat, we get 2, and we separate into 2 different compounds. Here's mercury oxide, add a little bit of heat, and we end up with liquid mercury and oxygen gas. Again, this is what I call decomposition reaction. So the third one that we're going to talk about is called single displacement. Have 1 element and 1 compound in solution, and the element actually switches with the cation in solution. This happens with more advanced acid-base reactions. For example, we have, let's go aluminum solid, and we have 3HCl. This is in water. This is hydrochloric acid. And actually, to make this balanced, I'm going to put a 2 in front of here and make this a 6. And what usually happens when we add acid to aluminum, it bubbles really fast, and we end up with 2 molecules of AlCl3 in solution, and we're going to get 3 molecules of hydrogen gas being produced. So the hydrogen will switch out with aluminum, becomes its elemental form, and aluminum will end up with the chlorine. This is one type of single displacement reaction. This is a little bit more advanced, but you get the idea. Another one is when we have nickel and copper plus nickel nitrate. The elements will switch. Nickel will become a solid, and we have 2 of those. No. Oh, other way around. We don't have a 2 in front of that, sorry. I'm forgetting which reaction I'm doing. And then we have Cu and O3 too. So we'll end up with a bluer solution. So this is how this works. This is what we call elemental switching. It's called single displacement because one of the reactants over in this area, switches with another one, and it's just one element involved in the switching. Then we have double displacement. We've got 2 compounds in solution, and the cations switch places. So we have AB and then CD. The C switches with A, and we have CB and AD as the products. And usually this is one I like to give. So we have lead nitrate plus, let's go with sodium iodide or potassium iodide. It doesn't matter. We've got 2 of these. to make sure we balance the reaction. And we end up with PbI2, which is a very brilliant yellow compound. And then we have So2NaNO3 in solution. And this is a solid. So when we add these two are in water, these are both aqueous. And what we have is that they switch out and we end up with a bright yellow solution, solid on the bottom of a clear solution. This is the fourth type of compound. This is double displacement. And these are, well, what we're doing is actually switching either elements, different parts of the element, compounds, elements, or ions, and end up with a solid or some type of physical change that we can't reverse. Now, combustions, this is one of these few specialty reactions. This is actually something we call a type of redox reaction. So this is actually what I call reduction oxidation. We'll talk about this a little bit. Actually, we got about half a semester talking about combustion and redox. And what happens is that the electrons move. Electrons move as well as elements, especially in combustion. Now with combustion, we take methane, add oxygen, we get carbon dioxide and water. And so with a combustion type of reaction, you're going to get this type of movement. Now when we talk about redox reactions, we'll talk about that a little bit later. It is very, very complex, and you guys are going to get to learn it. And so, but with redox and with these, we're actually looking at how electrons move. Because in order for this to work, electrons are hopping between these two elements, two compounds. Oxygen is going to gain electrons. Carbon and hydrogen is going to lose a little bit. So there is actually some electron movement in this reaction, in these combustion reactions. Now, when we're balancing, you need to know what all these means. Reactants or reagents, the stuff that we start with, that's on the left of the arrow. And products is on the right. So that's what we end with. This is what we start. S is solid. L is liquid. G is gas. This is aqueous or dissolved in water. And this means heat. Now, we've seen this before, guys. If you've taken physics, this also means change. So we're looking at a change of temperature, usually adding heat to the mixture. This is chemistry, not physics, so make sure we understand that differentiation. Now, when we have a reaction, we have a little reaction arrow, reagents and products. Sometimes we have a single arrow, sometimes we have a double arrow, something like that. And the reaction conditions are listed underneath the arrow, and they could be temperature, catalyst, solvents, heat, inhibitors, pressure, or any other information that will help you do the reaction. And we got to see that as we go through this semester. Now, when we look at balancing reactions, mass is conserved. And how we do that is when we look at the reaction, atoms on the left equals atoms on the right. So this is a double displacement reaction. We know that iron and chromate are going to switch. So we're going to end up with iron, the reaction is going to be Fe. We know we got 3 anions here because 3 nitrates. So we need to have 3 chlorines. Plus now, there are our products, but what happens is we don't have this balance. So we got Fe, we have, I'm going to just put NO3 because they don't break out. So if you want to put N and oxygen together, you can. Then we got chlorine and chromium. We got 1 of each on each side. We have 6 on the left, 3 on the right. 3 here and 3 here. We have 1 iron and 1 chromium. So these are balanced, these are not. So we need 6 chlorines 3 more chlorines on the right for a total of 6. to do that, we need to put a 2 in front of this compound, meaning we got two molecules of FeCl3. So we end up with 2 Fe, and we're going to have 2 times 3 is 6 chlorines. Remember how we did this last year. And then now we need, so we got 2 over here. Now we need to balance the ions because the ions are not correct. So we need to put a 2 right here. So there's my 2. And that means I got 6 on the right. And I want to point out something. I made a mistake over here. This is supposed to be 6, not 3, because this is chromium 6, not chromium 3. So I need to have 6 nitrates to balance that out. So since I corrected my mistake, that's the balance equation. You're going to have some more of this practice in OWL and on a practice sheet, which I'm going to hand to you. That's it for today.